Today we are taking the anti-lag system into a workshop, and let's talk for a moment about how it differs from rev limiter and launch control. Please remember to like, comment, and subscribe for the algorithm. Thanks. A distinctive sound reminiscent of loud shots, or as many people describe it, popcorn popping and flames coming out of the exhaust pipes, do not mean that the car is damaged. It's the anti-lag system. Anyone who has ever driven a car with a turbo engine knows how much power and torque a turbine adds to any car. What's not cool about turbo? Of course, it's the lag. Using the engine's exhaust, the turbine takes time to wind up. The larger the turbine, the greater the rotational inertia, and consequently, the turbine needs more time to fully generate the appropriate working pressure. One way to reduce lag is to use more turbines in the engine. We're talking about twin turbos or sequential systems. Whether you're competing in parallel races or drifting, you expect your car to respond immediately to the throttle. The anti-lag system causes the turbine to buffer and maintain pressure all the time, even if you let go of the gas. It also produces a sound similar to a fireworks and also shoots fire from the exhaust pipe. How does anti-lag work? The anti-lag system ignites an additional mixture of air and fuel in the exhaust manifold or the turbine housing instead of in the engine cylinder. The exhaust side of the turbine housing is very hot, which is utilized by the anti-lag system. Thanks to this, the mixture automatically ignites, and the additional explosion generates even more heat. There is also an increase in pressure in the exhaust manifold, which keeps the turbine spinning even when the throttle is closed. So, when you press the gas again, the boost you like so much is already waiting for you, fully ready. This trick works very well and can be used in all turbo cars, but as you can guess, not without any impact on our car. These additional explosions and even greater temperature heavily strain the entire exhaust manifold and the turbine itself. It can be so destructive that racing cars competing in, for example, WRCs often have to replace the turbine after each race. And that's not cheap. That's why new turbocharged cars are not sold with an anti-lag system. Accountants accustomed to high-performance engines, which are supposed to last at least until the end of the warranty, would never agree to it. No one would give a 100,000-kilometer warranty for such a car, rather 10 kilometers. However, if you're ready to blow up the extra mixture in the exhaust manifold, there are several ways to do this. The first is the so-called throttle kick. The second is an anti-lag system that uses a throttle bypass. In this system, the throttle remains open all the time, even when you are not adding gas. This, in conjunction with ECU tuning, delays the ignition and changes the amount of air relative to the fuel to create a much richer mixture. During typical burst combustion, the ECU controls the spark plug to ignite the mixture when the piston is close to its highest top, dead center point. As a result, we get the most efficient fuel combustion and the engine generates the most power. With delayed ignition, the spark plug ignites the mixture when the piston is already going down as low as possible. The mixture does not burn completely and is partially pushed to the exhaust manifold. It is there and still burns while exploding. This winds up the turbine. Another type of anti-lag is the rally system, also known as secondary air injection, which is often found in WRC cars. The throttle is no longer open all the time. Instead, a special bypass is added right in front of it, which constantly directs air directly to the exhaust manifold, bypassing the throttle. The bypass valve and solenoid precisely control the airflow, while the ECU ensures the correct fuel mixture. Modern racing cars have special systems that control the different aggressiveness settings of the anti-lag system. This allows the driver to select the appropriate gas response depending on the conditions and terrain. Importantly, it also allows the system to be completely turned off, saving quite expensive turbo parts. Now that we know what anti-lag is, how does it differ from the rev limiter that often appears in this topic? It is worth mentioning that in some cars competing in parallel races, you can hear similar shots and see fire from the exhaust pipe. It does not have to be an anti-lag system, but just a two-stage rev limiter. As you might have guessed, it consists of two different maximum rotation limits. The first is usually quite below the red line on the tachometer. You may also know it as launch control, which is the startup procedure. In high-powered cars, you don't need or want to rev the engine all the way to the red line to get off the start line as quickly as possible. The first RPM limit is set to ensure optimal wheel grip at the start. The second is at the edge of the red field, and is to prevent the valves from going into space and the car from blowing a hole in the engine block when trying to pull the next gear to the end of the tachometer. As you add gas and approach one of the two rev limiters, the car starts a safety procedure, for example, fuel cut or throttle closing. What happens when the mixture in the cylinders fails to burn? That's it, popcorn and fire from the exhaust pipe. However, remember that this is the first step to destroying the catalyst, which is also not cheap to replace. Well, unless it has been cut long ago. Launch control and anti-lag seem similar, but they are two separate computer functions controlled by the mix ignition delay. Unburned fuel flows from the cylinders into the exhaust manifold, which as a side effect is better winding of the turbine and a shot of fire from the pipe and loud sound of explosions. Both systems are sometimes confused because sometimes the anti-lag system is used for launch control. That's it for today about anti-lag and launch control. Until next time, take care and remember, drive safely.